Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about disk scheduling algorithms. There are 6 different types of disk scheduling algorithms. In this, we have seen about first come, first serve, SSTF, scan, C-scan and look and C-look. In this session, we are going to see about swap space management. What do I mean by swap space management? So, overview of this presentation, we are going to see about swap space management. So, before going to swap space management, let us know the definition. What do you mean by swapping? Swapping is nothing but interchanging of two processes from one process to another process, process A or process B. They will be interchanging. So, here the definitions comes as swapping is a memory management technique used in multi-programming to increase the number of processes by sharing its CPU. So, here the swapping in the memory management technique is used in multi-programming to increase the number of processes which are used by the central processing unit, nothing but CPU. And next, it is a technique of removing a process from the main memory. So, it is a technique which is used to remove the process from main memory. Suppose main memory is consisting some n number of processes A, B, C. Let us say P1, P2, P3. So, it is a technique of removing one process, means P1 will be removed by use from its main memory and storing it into a secondary memory. So, P1 will be removed from main memory and it will be placed in the secondary memory, nothing but secondary memory, and then being it back into the main memory for continued execution. So, if the process is not removed from the main memory, then it will start continuing its execution unless and until the process which is removed from the main memory and moved to secondary memory, if it is not swapped, means the place itself is in P1 position only, then only it can be continue its execution. When it is swapped, it cannot continue its execution. That is how we are going to swap each process from main memory to secondary memory. This action of moving a process out from main memory to secondary memory. So, here when you are moving from main memory to secondary memory, it is known as swap out. So, the action of moving from one process to another process, nothing but main memory to secondary memory, then it is called as swap out. Main memory to secondary memory, then it is known as swap out. Next, and the action of moving a process out from secondary memory to main memory is known as swapping. So, when you are moving main memory to secondary memory is swap out, and from secondary memory to main memory is swap in. So, that is the difference between swap in and swap out. Means swapping from main memory to secondary memory is known as swap out, and moving secondary memory to main memory is swap in. So, that is the difference between swap out and swap in. So, next, swap space management is another level task of the operating system. It is one of the another low level for operating system to complete its task. Disk space is used as an extension of main memory by the virtual memory. Here, the swap space management is one of the low level to complete its task in operating system, whereas in disk space is used as extension of main memory by its virtual memory. So, whatever the extension used by this main memory is swapped into virtual memory. As we know the fact, the disk access is much slower than the memory access. So, whatever you are accessing the disk from main memory, that will be slower when compared to secondary memory to main memory. So, here the memory gets slower. In the swap space management, we are using disk space. So, in this swap space, we are using some disk space. Suppose here there are n number of processes. If there is swap space, means any process is not placed. The swap is, we are having some space, that is what swap space, and that we are using as disk space. So whatever the place is, position or place is left for a space, that is we are using as disk space. So it will significantly decrease system's performance. It decreases some system's performance. So whatever you are placing with the swap space, that is used as disk space, and here the disk space will be decreasing its system's performance. Basically, in all our systems, we require the best throughput. So we are choosing one best throughput for based on all the required systems. So the goal of the swap space implementation is to provide the virtual memory to the best throughput. So whatever you are taking as the best throughput throughout from all the systems, that are used in swap space. The goal is what? To implement the swap space by the virtual memory to get its best throughput. In this article, we are going to discuss how swap space is used when swap space is located on disk and how the swap space is managed. So here we are placing one position for swap space, means you are locating the position for swap space. So location is something 002. So 002 is the location of this swap space. So here you are locating that on a disk. And how this swap space is managed, means when comparing to other processes, how we are going to process this swap space on the disk by using the swap space and how it is going to manage. So let us see, in the previous slide we have seen about swap space, how we are going to manage. Now we are going to see about what is the use of swap space use. So swap space is used by the different operations in various ways. So we are using various operating systems in n number of ways. Let us see one by one for swap space, how it is used in the operating system. The systems which are implementing swapping may use swap space to hold the entire process. So here, whenever the systems which are implementing for swapping, they are using some swap space to hold the entire space. So in this process, the entire space is occupied by swap space and hold the entire process. So hold this P1 process entirely. So total this swap space is used, which may include image, code and data segments. So this may include some image, data and something like code segments. So whatever that used by this swap space. So the process may be as image or any data or any code segments. Paging systems may simply store pages that have pushed out of the main memory. So the pages which are placed in the main memory, that will be pushed out from the main memory by using this paging system. This is one of the swap space use. The need of swap space on a system can vary from megabytes to gigabytes. So these bytes of the these swaps may be spaces may be megabytes to gigabytes. So the size of the image or any data, that may contain megabytes to gigabytes. But it also depends on the amount of physical memory. So it also depends on some physical memory. The virtual memory, it is backing and the way in which it is using the virtual memory. So whatever the virtual memory is backing and the way which is used by its virtual memory, that depends on the physical memory which is used by how much that space is occupied. That space is occupied by megabytes to gigabytes, whereas this virtual memory is backing and the way which is used by this virtual memory. The virtual memory itself backs its virtual memory again. So following table shows different systems using amount of swap space. So system, and what about swap space? Solaris system, equal amount of physical memory. So in this Solaris, it will have equal amount of memory. It may contains each 2 bytes to 2. So it contains equal of amount of physical memory. Whereas in Linux, that double the double the amount of physical memory. So here 2, no, it consists of double, means 2 into 2. It contains double of memory in Linux, whereas in Solaris it contains only single memory, that is 2 megabytes. So it depends on the memory which is on single, and Linux is on double. So Solaris single, Linux double. So what do I mean by swap space location? A swap space can reside in one of the 2 places. So what are the 2 places? Means normal file system and separate disk partition. So in this normal file system, the files which are placed normally, we can find out its location. Whereas in separate disk partition, we need to search each and every file. Why? Because we are separating folders into subfolders, and that folders or files we are giving as partitions. So that is how the difference between normal file system and separate disk partition can be used by this swap space. So based on the normal file system, we can find the file directly, whereas in partitions we need to search with each and every file by folders into subfolders or any files into subfiles. So dividing the disk into partitions. So what I mean by swap space management, let us see with an example. The traditional Unix kernel started with an implementation of swapping that copied entire process between contiguous disk regions and memory. In this Unix kernel, which is an implementation of swapping, that is copied from one process to another process by using contiguous disk regions. So this will be copied and disk regions and to memory. So one by one it will be swapping. Unix later evolved to a combination of swapping and paging as paging hardware becomes available. So in this Unix later on depends on the combination of swapping and paging, and this both depends on paging hardware when it is available. In Solaris, the designers changed standard Unix methods to improve its efficiency, whereas in this Solaris, the designers are changing its Unix methods to improve its efficiency. Whereas Linux is similar to Solaris system. In previous, we have seen Solaris is using single, whereas Linux is using double memory. In this as well as Unix improves its efficiency, whereas Linux is similar to Solaris. In both the system, the swap space is used only for anonymous memory. So here the swap space is using only anonymous memory. Here this swap space contains only some anonymous memory, so which is constant. The memory can't be changed. It is a kind of memory which is not backed by any file. That's what's constant. So it cannot retrieve or it cannot send any files back. In the Linux system, one or more swap areas are allowed to be established. So where compared to Unix or Solaris, in this Linux system, one or more swap areas are allowed to be established. A swap area may be in either in a swap file or a regular file system or any dedicated file partition. So the area of this swap area may be a swaps file, may be a regular file or any dedicated file. So based on that, the area will be depends, means swap space will be depends based on this file location. So that may be a regular file system or any dedicated file partition or any swaps file. That is what 3 regions can be used as swap area. So each swap area consists of 4 kilobytes page slots which are used to hold the swapped pages. So here each page slot consists of 4 kilobytes of memory. Associated with each swap area is known as swap map. So whatever it is swapping with this partition or file, that is known as swap map. So the location of one is swapping with first partition of the file, nothing but swap file. So this is swapping with 1 to 1. If the value of the counter is 0, it means page slot is occupied by swapped pages. So if the value of 0 means the page is occupied, means the slot is occupied by swapped page. So this page is occupied when it is 0. The value of counter indicates the number of mappings to the swapped page. So counter means it executes the next instruction or next file. Here the mapping done according to the swapping pages. For example, a value 3 indicates that the swapped page is mapped to 3 different processes. So 3 is mapped with 3 different processes. So 1, 3, 1. So 0 indicates the swap page is occupied, whereas other 3 are with different swapping pages. So this is how the swapping done with the swap partition or a swap file or a swap map. So each slot is known as page slot. This total is known as swap area. So whatever the partition of these files may be regular file, dedicated file partition or disk partition. So these all are considered as swap area, and each will be mapping according to the given number. And when it is under 0, the page will be occupied. When it is in the numbers, the pages gets free. This is how the data structure for swapping in Linux system. So in this session we have seen about swap space management. And we have seen the definition of swapping. And what do you mean by swap in and swap out, and implementation of swapping. And next, pages, how the pages is done with the swap space and swap space area also. So if you have any doubts, you can comment in comment box. Thank you.